You're listening to Fire Ecology Chats, a podcast series by the Association for Fire Ecology.
Hello, everyone. My name is Bob Keane. I am the editor-in-chief of the internationally renowned journal Fire Ecology. Today, we're going to be talking about a very, very important paper. The title of the paper is When Do Contemporary Wildfires Restore Forest Structures in Sierra Nevada? There is a who's who of author list here, and we have two of the authors here to talk about the paper. We have the senior author, Caden Chamberlain, and junior author, Meyer. Caden, can you introduce yourself?
Hi, Bob. Thanks for having us. My name is Caden Chamberlain. I am currently a postdoc at Colorado State University and the Rocky Mountain Research Station in Fort Collins, Colorado. And at the time of writing this paper, I was a PhD student at the University of Washington.
Well, welcome, Caden. Thanks for giving your time and talking about the paper. Marc, how about you?
Hey, good morning, Bob. My name is Marc Meyer, and I'm a province ecologist with the USDA Forest Service based in the Pacific Southwest region, which is mostly California.
Well, welcome to you as well. And Caden, why don't you tell us about the paper?
Yeah, so the motivation for this paper really stemmed from the idea that when we look at our dry forest ecosystems in California, Sierra Nevada, and across Western North America, we know that these forests currently lack resilience to climate change and subsequent disturbances. And this is primarily due to a history of fire suppression and exclusion, and also increasingly warmer and drier conditions. And so because of this, there are currently these national and state level efforts that are really focused on increasing the pace and scale of restoration treatment, with the general goal to restore forest structures, compositions, and function, and increase ecosystem resilience. However, what we also know is that area burned by wildfire is increasing rapidly every year, both in California and across Western North America. And area burned actually tends to outpace the implementation of these restoration treatments on an annual basis. So there's been a lot of research documenting the increase in high severity burned area, but we also know that all contemporary fires contain at least some portion of low and moderate severity effects, which can have these more restorative and beneficial ecological outcomes. Our study really focused on evaluating the capacity of contemporary wildfires for restoring forest structural patterns to better understand when and where these fires can be leveraged as a management tool for increasing dry forest resilience.
To me, it's the canary in the coal mine in that if we don't pay attention to these forests, we're going to lose, a lot of very important ecological attributes. And what I loved about this paper was the methods. Could you tell me a little more about the novel methods that you used?
Yeah, so I think one interesting part about this study is the methods that we use to define restorative fire effects. We developed a somewhat novel approach that relied on this data set of contemporary reference sites in the Sierra Nevada. We have another paper that describes these reference sites, but the idea is that these sites represent existing areas in the Sierra Nevada where a frequent and low to moderate severity fire regime has been mostly reestablished. And so forest structures and compositions within these sites are expected to be more resilient to subsequent disturbances. And so for this study, we use these contemporary reference sites to define natural ranges of variation of three key structural metrics using airborne LiDAR data. And then we evaluated post-fire structural conditions against these reference targets to assess the restorative nature of contemporary wildfires. I think the novelty of these methods is that we are really demonstrating how these contemporary reference sites, coupled with these high fidelity remote sensing data sets like airborne LiDAR, can be used to define these really detailed and site-specific targets for restoration treatments.
That's pretty cool stuff. I really enjoyed reading that. Could you tell us kind of quickly what the take-home message is about the results from this study?
Yeah, we have a bunch of results, and I encourage folks to read the paper. But today we're going to highlight just three key results. So the first one is that our results suggest that first entry wildfires were only moderately successful at producing overstory structural patterns that aligned with those contemporary reference sites. Restorative effects were most common within moderate severity patches, but large extents of these post-fire landscapes will require additional low to moderate severity fire effects or planting in some cases to truly achieve the low fuel loading and the fine-scale tree clump and opening patterns associated with fire-intact ecosystems. The second message we wanted to share is that we found that distance to past fire was a top driver of restorative fire effects. And so this suggests that landscapes that are characterized by mosaics of past burns, even if the entire landscape has not burned, are more likely to experience more restorative fire effects when subsequent fires do occur. What this means is that as more small fires burn burn and break up our fuel-loaded landscapes, opportunities for restorative fire effects will increase in the future. The last one here is that our predictive maps of the probability of restorative fire effects showed that up to 58% of yet unburned sites in the Sierra Nevada would be likely to experience restorative fire effects under mild fire weather conditions. This means that there are these extensive areas where wildfires could be better leveraged to increase the pace and scale of forest restoration efforts in the Sierra Nevada.
Yeah, that's really important. More important are the management implications for those results. Marc, you want to speak to those management implications?
Sure, Bob. I think there's several important implications of this paper. First, this study suggests that low to moderate severity fire is not typically a one and done type of treatment when it comes to restoring the structure of these yellow pine and mixed conifer forests of the Sierra Nevada. Rather, additional fire entries or post-fire treatments such as prescribed fire or mechanical thinning are needed to achieve full structural restoration. But, it's also notable that about a quarter of the moderate severity burned areas achieve their full structural restoration indices and targets, which is pretty remarkable considering that these forests have typically not seen any fire for about a century and a half. Secondly, the LiDAR-based indices could help forest managers locate priority areas for post-fire restoration treatments and identify which treatment prescriptions are most needed, such as the use of prescribed fire to reduce lighter fuel densities. And thirdly, the study could really help locate areas in the Sierra Nevada that are most likely to see restorative fire effects from a first entry wildfire under mild to moderate fire weather, as Caden was just speaking to. This is especially evident in many of the higher elevation mixed conifer and yellow pine forests in the bioregion.
Yeah, that was really important. That's what I loved about this paper is it has resounding effects for managing fires, not only in that area, but for managing fires across the United States and even across the world. I'd want to thank you both for coming on this podcast. Caden, do you want to recognize any funding or co-authors?
Yeah, of course. So I'd like to start by recognizing Marc Meyer, who's on the call with us today. And then I'd also like to recognize the other co-authors, including Malcolm North, Bryce Bartle-Geller, Alina Kanzler, Liz Van Wagtendonk, Hannah Redford, and Van Kane. And then, I'd like to finish by thanking the NASA Finest Research Grant, which funded this study in its entirety.
Yeah, I wish Alina and Liz could have come on this call. We could have really had some fun, but I want to really thank you two for telling us all about that. Listeners, if you are interested in this paper, guess what? You can download it for free. Yes, for free from our journal website, Fire Ecology. Fire Ecology is published by Springer and overrun by the Association for Fire Ecology, AFI. And with that, I'd like to invite you to come to our next Fire Ecology Chat. Thanks for listening.
Thanks, Bob.
Thank you for listening to Fire Ecology Chats, a podcast series by the Association for Fire Ecology. If you enjoyed this episode, subscribe to our show and leave us a review. To learn more about fire ecology and support our future work by becoming a member, visit fireecology.org. FireEcology.org.